Hey guys, today we are going to look at scatter plots and associations. All right, so here's a scatter plot. This is an example of what one would look like. We're going to have an X and a Y axis, and we're going to see several points on our graph, and they're not going to be connected. They're all going to be disconnected from each other. All right, so here we're measuring the number of items and then the number of dollars spent total. So our goal today is going to be to determine the association of data by examining a scatter plot. We want to see what can we figure out about the trends of this data. All right, so a few definitions here. Scatter plots are graphs that use points to display numerical data with two variables or bivariate data. So numerical data is just anything that we can measure with numbers. So height would be numerical, weight would be numerical, an amount of money would be numerical. And then bivariate data just means we're measuring two different variables. Scatter plots can help determine if one variable has an effect on the other, or if there are overall trends, patterns, or associations between variables. So we're going to use our scatter plots to try to analyze what's happening in our data, what type of trends are going on. All right, so here's the first type of association we're going to look at is we're going to have either positive, negative, or no association. For positive, as one variable increases, the other variable also increases. All right, so in other words, the variables are going to change in the same direction. So if one increases, the other one increases. It's actually going to be same but opposite. If one decreases, then the other one also decreases. So we want our variables to be moving in the same direction for them to be positive. So think about it this way. If I go from left to right, I'm increasing in my X values. And as I go from left to right, my points are going up. They're going up, which is on the y-axis, increasing in y values. So as we increase our x, we increase our y. The same thing is true, though, if I go to the left. As I go to the left, my points are going down. So as I'm decreasing in my x, I'm also decreasing in my y. Okay, so this would be a positive association. Next is negative. So in negative associations, as one variable increases, the other variable decreases. They do the opposite things. The variables change in opposite directions. Okay, so think about here, as I increase my x value, go from left to right, my points are going down, their y values are decreasing. So as one variable increases, the other one decreases. That means it's a negative association. And last, we have no association here. That means that the change in one variable has no effect on the second variable. So as you can see here, as we increase from left to right on the x-axis, nothing's really changing about where my points are on the y-axis. It just kind of is just a big blob of points. So that's what we would call no association. There's no trend. All right, so we're going to describe the type of association that we would expect to see based on our variables. So here I'm just going to read what variables I have and decide is it going to be positive, negative, or no association. So the number of shoes a person owns and the number of states they visited. So I'm going to think about, as the number of shoes that I own, as that increases, how is that going to affect the number of states that I visit? Well, realistically, I don't see a connection between those two. I could own a lot of shoes and never go anywhere, or I could go a lot of places, right? Just because I have a lot of shoes doesn't mean anything about the number of states I'm going to visit. So I would probably say that is no association. They don't really relate to each other. All right, number 2, it says the size in ounces of a steak and the cost of the steak. Well, typically, as my size of steak increases, usually that would mean that my price would also, the cost of the steak would also increase. Okay, since both are increasing, that is going to be a positive association. I could also think about it the other way. As the size of the stake decreases, so if I get a smaller stake, typically the cost of the stake will be smaller. Since they're both decreasing, it's still positive. Okay. Finally, for number 3, I have the number of days since watering a plant and the moisture level of the soil. So as the number of days since watering the plant increases, meaning the longer I go without watering the plant, the moisture level of the plant is going to decrease. So since they are going in opposite directions, I would say that would be a negative association. Okay. All right, there's one other thing we're going to look at with association, and that is the strength of the association as well as whether it's linear or nonlinear. Okay, so if data points are close together, the association is what we call strong. And if the data points are widely spread, the association is weak. Okay, so looking at these two graphs, I would say this one on the left is going to be a strong association because my points are pretty close together. This one, they're a little bit further apart, so I would say that would be a weak association. All right, and here we have linear versus nonlinear. Linear means that if a straight line can be drawn to show the overall trend, that would be a linear association. Okay, for example, looking at the one on the left, I can draw a line, even though all the points are not on this line kind of follows the pattern of the points, so that would be called linear. They follow the pattern of the line. Here, though, these points, they kind of make this U shape if I follow the pattern. Okay, so that would be nonlinear. All right, so let's use everything we know about associations to see if we can answer these questions. Here are our 4 graphs we're going to look at, and it says, number 4, which scatter plots show linear association? So I'm looking for which graph would follow the pattern of a straight line. Okay, I'm thinking A. I'm just going to go through each one. I'm thinking A, if I follow these points, there's a curve to this graph. So I'm going to say this one is non-linear. Okay, B, if I kind of follow my points, that one I would say is linear. I can draw a straight line and it goes in the same direction as all the points. All right, C, same thing. I can draw a line and it follows that pattern, so that would be linear. D, if I follow my points, I'm going to start to curve down at the end, so that one would be non-linear. All right, so when I say which ones are linear, I would say graph B and C would be linear. And then number 5 says which scatter plots show nonlinear association, so I would say that would be A and D. Number 6 is which scatter plot shows the weakest association. So in other words, in which graph are the points the furthest apart from each other? I would say out of all 4, I think letter C would be these points are the furthest apart from each other. And then number 7, which scatter plot shows the strongest association? I would say graph A. Those points are very, very close together, so that would be a strong association. It doesn't have to be linear for it to be a strong association. All right, and there are scatter plots and association.